with the properties that we have and the concepts that we have, we are now ready to solve exponential and logarithmic equations. Example, solve 2 to the 3x minus 2 equals 5 for x. So we are asked to find the value of x that would satisfy this equation. Take note that we cannot apply the method, which is the exponential method that we used a while ago, in creating the both sides of the equations with the same base, since 5 cannot be expressed as expression with base 2 and exponent something. So in that case, we will find another way. And to solve this one, we will find ways to get the variable x out of the exponent. And we can only do that if we use logarithms. Okay? We use logs to get x out of the exponent. So how do we do that? We have 2 to the 3x minus 2 equals 5 is equivalent to log 2 to the 3x minus 2 equals log 5. What rule is this? This is just rule number 8. Okay? If m equals n, then log of m is equal to log of n. Here, since we already have the common logarithm, we can use common logarithm. So we don't have to write the base 10. From here, we can have 3x minus 2 log of 2 equals log of 5. Then, dividing both sides by, from here, how did we express this one from here? Using the property number 7. That's why, guys, you have to familiarize these 8 properties. So this is dividing both sides by log 2. We have 3x minus 2 equals log 5 over log 2. Take note, this is division of 2 logs. Okay, you cannot express that one as log of 5 over 2. It's log of 5 divided by log of 2. And you can already find the value of that using your calculator. Or you can just you can use addition property of equality to eliminate negative 2 on the side of x. So we have 3x equals 2 plus log 5 over log 2. Dividing both sides by 3 or multiplying both sides by 3 by 1/3, we have x is equal to 1/3 2 plus log of 5 over log of 2. So this is enough. Or if you want to expand this one using your calculator, x is approximately 1.44. Okay, let's have another example. Let y equals e to the x plus e to the negative x over 2. Solve for x if y is equal to 2.5. So solution, y is equal to e to the x plus e to the negative x over 2 is equivalent to 2.5 equals e to the x plus e to the negative x over 2 since y is equal to 2.5. So just substitute. And then multiplying both sides by 2 to eliminate the denominator, we have 5 equals e to the x plus e to the negative x. Take note that e to the negative x is just 1 over e to the x. So we can have 5 equals e to the x plus 1 over e to the x. So we can multiply e to the x on both sides to eliminate the denominator again to make it simpler to solve. So we have 5e to the x equals e to the x times e to the x plus 1. And this one here is just e squared e to the 2x. So that's 5e to the x equals e to the 2x plus 1. Now combining everything on the left side so that the right side will be 0. So we have 5e to the x minus e to the 2x minus 1 equals 0. Or you can have negative e to the 2x plus 5e to the x minus 1 equals 0. You can multiply negative 1 on both sides so that it becomes e to the 2x minus 5e to the x plus 1 equals 0. As you can see, this is a quadratic expression or a quadratic equation. For you to solve it easier, you can just use another variable to substitute e to the x so that it would be easier for you to factor out. Example, we can let u equals e to the x so that this expression here is just u squared minus 5u plus 1 equals 0. So is there a factor of this? If none, then we can use the quadratic formula. We can just use the quadratic formula. Our a is 1, our b is negative 5, and our c is 1. So we have u is equal to minus minus b, that's minus minus 5 plus minus square root of negative b squared minus 4 times a times c over 2 times a. So that's 5 plus minus square root of 25 minus 4 over 2. Or that's 5 plus minus square root of 21 over 2. And take note, our u is e to the x. So therefore, this one here is e to the x. Now, how to find x there? How to solve x? We can apply this one. This is equivalent to ln e to the x equals ln of 5 plus minus square root of 21 over 2. Okay, again, that's rule number 8. That's rule number 8. Where is rule number 8? This one. Okay. If m is equal to n, then log of m is equal to log of n. So here we just applied the natural logarithm since we are involving e on our equation. So that means that our x, okay, our x is just, because take note, ln of e to the x is just x. That is ln of 5 plus minus square root of 21 over 2. You can use calculator to solve this one or not. This is enough. Okay, this is enough. Take note, guys, how we came up with this. If you are confused, take note that ln of x is just equal to log e of x. Okay, and then if if our x is e to the x, we can have ln e to the x is equal to log e of e to the x. Okay, so we just substituted x here with e to the x. Okay, and then from here we have, using the log b to the x from one of our rules equals x. So we have x equals this one, this ln e to the x is just equal to x. That's why we came up with this one. This ln e to the x is just x. Okay, from this expression. Another example. Solve log x plus 3 plus log x equals 1. Solution. This log x plus 3 plus log x equals 1 is just, this one is just addition to multiplication, so we can write that one as log x plus 3 times x equals 1. Okay, from rule number here, rule number 5. So from here we have, take note, the log here has base 10. Okay, that's a common logarithm. So we can write that one as x plus 3 times x equals 10 to the 1. Okay, eliminating the log, we express this one in this form. Take note of the definition. The log, take note of the definition, guys. The log of x equals y is equivalent to x equals 10 to the y. So here, our x is the entire x plus 3 times x. Our y is 1 and our b is 10. So therefore, this is x squared plus 3x equals 10, or x squared plus 3x minus 10 equals 0. Can we factor this out? Yes, the factor is x plus 5, x minus 2 equals 0. So we have x equals, negative 5, x equals 2. But before we conclude that these are the solution, let's substitute first to our original problem. So we have, for negative 5, we have log to the negative 5 plus 3 plus log of negative 5, is it equal to 1? Take note, this is log negative 2 plus log negative 5. Okay, and this here, the log negative 2 and the log negative 5 are not defined. Okay, they are not defined since the domain of the log function is 0 to positive infinity. Remember that the range of the exponential function is 0 to positive infinity, and that is the domain of the logarithmic functions. And since these values here are negative values, so therefore it is beyond. Okay, it's not part of the domain of the logarithmic functions. So negative 5 there is not a solution. How about 2? So we have log 2 plus 3 plus log 2, is it equal to 1? Let's check. So that's log 5 plus log 2, is it equal to 1? Here can be written as log 5 times 2, is it equal to 1? So that's log 10. Take note that again we have 10 here as a base, and this log 10 of 10 is just equivalent to 1, which is 1. From what? From here. From our rule, this one. Log b of b equals 1. So log 10 of 10 is equivalent to 1. So therefore, our solution is 2. But negative 5 is not. So let's have another example here. Solve ln of x squared is equal to ln of x squared. So to solve this one, we have ln of x squared equals ln of x squared is just equivalent to ln of x squared equals 2 ln of x. Remember the rule number 7. So from here, we have ln of x squared minus 2 ln of x equals 0. So applying addition property of equality. So take note, we have common factor, ln of x. So we can factor out ln of x. So what remains here is ln of x, here is 2, equals 0. So therefore, by zero product property, we have ln of x equals 0 or ln of x minus 2 equals 0. Now this one here, this ln of x is just x equals e to the 0. Remember the definition, okay? But our base here is e since we are in a natural logarithm. So that's x is equal to e to the 0, which is 1. Here we have ln of x equals 2. Again, applying the addition property of equality, which is x equals e squared. Now, these are the solution, 1 and e squared. Questions? So let's have some problem sets, practice problems. So let's have these practice problems. Try to solve them on your own.